Now we'll discuss the properties of joint density function. Okay, the properties of joint distribution density function are, first one is what? The joint density function is non-negative non-negative number. Okay, so if you it is a non-negative number, that is f xy of x comma y value will be always greater than or equal to 0. And what is the second case? The second case is that the total area under the joint density function, the total area under the joint density function is having the value 1. Okay, so this is the same, it is just extension of whatever properties we have discussed for probability density function. The same will be extended for joint probability density function. Okay, and third property says that the relation between density function and distribution function. So that is the what is joint distribution function? The joint distribution function will be integral of density function. Since it is function of two random variables, we have to do integration two times here. Okay. And similarly, the probability of joint event. What is the probability of joint event? Here it is given as x1 less than x less than or equal to x2, y1 less than y less than or equal to y2 is given as, what is the probability of x1 less than x less than or equal to x2, y1 less than y less than or equal to y2 will be equal to, it is integral x1 to x2 integral y1 to y2 f xy of x comma y dx dy. Okay, so this gives us what is the joint uh, probability of joint event. Okay, now we if you want to obtain marginal distribution functions, we know that what is capital Fx of x. For marginal distribution function, f capital Fx of x, what is y will be infinity. So we will be doing the integration minus infinity to plus infinity for y term, whereas the x term is having the integral minus infinity to x. Okay, similarly the marginal distribution function fy of y, here what is x range ma? In the integration the x limits are minus infinity to plus infinity, whereas the y limits are minus infinity to y. Okay, so this gives us what is that marginal distribution functions, that is fx of x and fy of y. These two these two these two are called marginal distribution function. Okay, whenever they ask you to find out marginal distribution function, you have to find out what is fx of x and fy of y, both you have to find out. Okay, and similarly what is marginal density function? Marginal density function will be, it is equal to integral minus so here we are taking fx of x, no, fx of x, so you have to do only one integration with respect to y, whereas the y limits are minus infinity to plus infinity. So integral minus infinity to plus infinity fx of x x comma y dy. Okay, so what is this? This is nothing but the derivative of distribution function, where in this distribution function y term will be equal to infinity. Okay, similarly fy of y. So in fy of y, what is that we do? We do integration with respect to x, and the limits of integration will be minus infinity to plus infinity. Otherwise what we do? We can do derivative of distribution function with x is equal to infinity and y with the corresponding values. Okay, so that gives us what is that? The marginal density function. Now we'll see the proofs of this. Okay, so what is that marginal density function? It is sorry, joint density function fxy of x comma y will be equal to what? It is second derivative of distribution function. It is dou square fxy of x comma y dou x dou y. Okay, now we know that what is distribution function? It is the probability of getting x is less than or equal to x, y less than or equal to y. Okay, it is the probability of getting x is less than or equal to x and y is less than or equal to y. Okay, now we know that what is probability of x less than or equal to x, y less than or equal to y? It is nothing but probability of x less than or equal to x intersection y less than or equal to y. Okay, so this is called, and we know that since the probability of x will be always greater than 0, probability of y is also greater than or equal to 0, then what is that? The joint probability of these two events. The joint probability of these two events will also be greater than or equal to 0. So fxy of x comma y, fxy of x comma y is non-negative number, because what is this numerator? This is non-negative. If it is non-negative, what happens to this derivative? Derivative is also non-negative. Okay, that is our first property. And the second property says that the total area under probability density function will be equal to 1. Okay, so what is this total area? What it gives us? It gives us the joint probability of random variables x and y. Okay, in the sample space, it gives us what is the joint probability of random variable in the sample space. Just now, whenever we have discussed that previous problem, what we did to find the k value, we just added all the probabilities. No, similarly here also, what is this here? It gives us the joint probability for the random variables x and y in the sample space. So we know that from the axioms of probability, the sum of all probabilities must be equal to 1. Okay, so that the area under the probability density function will be always equal to 1. Okay, and what is the third property? The third property says that, see here, the third property says that what is joint distribution function? It is derivative of density function. No, joint distribution function is derivative of density function. Okay, so that is why we know that what is density function? It is the second derivative of distribution function. Density function will be what? It is second derivative of distribution function. Okay, now what we do here, we integrate this equation on both sides with respect to x and y. If we integrate both these equations on both sides with x and y, what happens to the right side of the equation? Here we are also derivating with respect to x and y, and also integrating with respect to x and y. So the derivative and integrations will get cancelled. So what we get? We get fxy of x comma y. So fxy of x comma y will be equal to what? It is integral minus infinity to y, integral minus infinity to x, fxy of x comma y dx dy. Okay, so what is that? The distribution function will be integral of density function. Okay, so that is our third property. And what is the fourth property here? Fourth property is that to find the joint probability of joint event, that is the probability of x1 less than x less than or equal to x2, y1 less than y less than or equal to y2, we are using this fourth property. Okay, so from this we know that what is x1 value? Since x1 less than x less than or equal to x2 is given, no, in the statement, y1 less than y less than or equal to y2 is given. So from this we can say that x1 value is always less than or equal to x2, y1 value is always less than or equal to y2. Okay, now you see this, it is very important, students. Probability of x1 less than x less than or equal to x2, probability of x1 less than x less than or equal to x2 can be written as, what is x2 is higher than x1, no? Okay, x2, what is x2? Will be having more elements compared to x1. So if you want to find out what is the probability between these two, what is that we do? We find out what is the probability of x2 minus probability of x1. Okay, that gives us the probability between those two. Okay, so it is probability of x less than or equal to x2 minus probability of x less than or equal to x1. Okay, and similarly, probability of y1 less than y less than or equal to y2 is equal to probability of y less than or equal to y2 minus probability of y less than or equal to y1. Okay, so now we are interested to find out what is the probability of joint event, that is between x1 and x2 and y1 and y2. Okay, so just now we have discussed that how do you write this? Probability of x1 less than x less than or equal to x2, we can write it as probability of x less than or equal to x2 minus probability of x less than or equal to x1. Yes or no? Similarly, probability of y1 less than y less than or equal to y2, we are writing like this. Okay. So the same thing will be represented here. So if you observe this here, what is that? We are writing the same equations here. Probability of x less than or equal to x2 minus probability of x less than or equal to x1 intersection probability of y less than or equal to y2 minus probability of y less than or equal to y1. Okay. So from that we know that, see here, we we are combining these two terms. If you combine these two terms, how do you write it as y less than or equal to y2 minus y less than or equal to y1. See here, if you combine these two, what is that we get? Y less than or equal to y2 minus y less than or equal to y1. Okay. So we are combining that y terms here. We are writing this like this: y less than or equal to y2 minus y less than or equal to y1. Okay. So now what is here? We have intersection here, no? So it is probability of x less than or equal to x2 intersection y less than or equal to y2 minus y less than or equal to y1. Okay. And here on the other term, next term is what? Probability of x less than or equal to x1 intersection y less than or equal to y2 minus y less than or equal to y1. Okay. Now we just combine these two terms. Okay. See here. What is the range, ma? What is the range here? What is x range? X is less than or equal to x2. Means x range is 0 less than or equal to x2. Can you tell me what is the y range here? For first term, y range will be minus infinity to y2. For the second term, minus is here. This minus is considered here. For the second term here, y less than or equal to y1, the limits are minus infinity to y1. Okay. So fxy of x comma y dy into dx. Similarly, this terms. What is the x range? Minus infinity to x1. For first one, the limits are minus infinity to y2. The second term, the limits are minus infinity to y1. Okay. So we have got this. Now what we do here, see here we are what is y2? Y2 will be always greater than y1. Okay. The one integral is including the value till y2. Okay. One integral is including the value till y2, whereas another integral is including the value till x1. Okay. So that is why, what are the limits here? The limits are y1 to y2, whereas this x limits we have taken same thing, only we have combining these two terms. Okay. Similarly here also we are combining these two terms. So the limits of y will be y1 to y2 fxy of x comma y dy dx. Okay. What are the x limits? The x limits are minus infinity to x1. Now we have combined y limits. No, now we combine x limits also. What is x2 value? X2 value will be greater than x1. Okay. So the first one is having the limit till x2, whereas the second one is having the limit till x1. So the limits for x will be, what are the limits for x will be here? The limits for the x will be x1 to x2 integral y1 to y2 fxy x comma y dy dx. Like this, using this equation we can find out the probability of joint event. Okay. So that is probability of x1 less than x less than or equal to x2, y1 less than y less than or equal to y2 is equal to integral x1 to x2 integral y1 to y2 fxy of x comma y dy dx. Okay. Now we will see the fifth property. The fifth property will give us what is marginal distribution functions and marginal density function. What is marginal distribution function? That is fx of x or fy of a, or the marginal distribution function. Okay. In fx of x, what is y term? Y term will be infinity. Okay. And we know that the formula for the marginal formula for joint probability distribution function will be equal to the integral. double integral of density function. Okay, in this double integral, what is y term? Y limits are infinity. So if fx of x will be what? The y limit will be infinity. So it is equal to integral minus infinity to x minus infinity to infinity fxy of x comma y dy dx. Okay, so similarly for fy, what is x term? X term will be infinity. So we'll be having only y term. So the limits of x will be minus infinity to plus infinity. The limits of y will be minus infinity to y fxy of x comma y dx dy. Okay. So this is our marginal distribution functions. Now we'll find out what is marginal density functions. Okay. So we have marginal distribution functions. No, what is density function? The density function is derivative of distribution function. We already found what is fx of x from the previous step. So we are just differentiating fx of x with respect to dx to obtain marginal density function. Similarly, to obtain fy of y, what we have done? We have to do the derivative of, see here, what is that fy of I? The marginal density function will be what? Derivative of fy of y with respect to y. Okay. So since you have considered y, no, what is x term? X term will be infinity. X term, the limits of x will be infinity. So it is dy by dy integral minus infinity to y integral minus infinity to infinity fxy of x comma y dx dy. Okay. So from this, what is fy of y will be equal to integral minus infinity to plus infinity fx x comma y of x comma y dx. Fy of y will be what? It is derivative of distribution function.